Okay, seventh graders, today we're going to be doing a virtual lab using Think Central for our new textbook. So you're going to need to log into Think Central using the username and password that I helped you get onto last week. And when you get into Think Central today, you might notice that you have no assignments in this box. So in order to refresh your computer or your iPad, you're going to need to click on Old Assignments, and then everything that I put in your Think Central last week should be there. So I'll give you about 3 minutes to get logged into Think Central, then to find things to do. And what we're looking for today is the activity that is called What Makes a Healthy Heart. And you're going to need to click on it twice to launch the tutorial. All right, so we'll pause the video now. All right, everyone should be at the lab that is called What Makes a Healthy Heart. And the lab, you really don't need headphones. So you can read in the text box on the bottom, or you can turn your volume down. Because we're doing this mostly as a class, there are going to be times where you don't want the volume higher or lower. If you do have headphones today, I'd almost prefer that you not wear them, just so you can pay attention as we go through this lab together more as a class today than if you were doing it individually. So, what makes a healthy heart? In this lesson, you're going to investigate the effect that exercise has on the physical effort on your heart. So I finished this page, and I'm going to click the arrow to the next page.
A person's heart rate is usually around 60 to 80 beats per minute. Yet Lance Armstrong, an American cyclist and 7-time Tour de France winner, had a resting heart rate of about 34 beats per minute when he was in his best condition. How can you explain this? Type your answer in the box, then click OK.
Okay, so the person in the lab explains that Lance Armstrong has a resting heartbeat of 34 beats per minute, which is really, really low. Yours is about 60 to 80. So why might you think that Lance Armstrong has such a low resting heart rate? And I want you to type an answer in the box. And when you type the answer in the box, you can hit OK. And again, I'll give you about 1 minute to do this. Ready, set, go. Okay, time's up. You should have written something in the box, and now we're going to advance to the next page.
In order to understand
And on this page, I'm going to pause this quick. There are 5 different slides that it's going to show you, and at the bottom of each slide, it's going to explain some things about the heart and the cardiovascular system. So I am going to give you about 3 to 4 minutes to play through these little scenarios. I'm going to have the sub pause the video now while you play through these. So I'm going to pause my video now. You can play through these 5 scenarios and then wait to get started again. Well, you should have learned a little bit more about the heart by advancing through those 5 different pages, and you should have learned a little bit about more with your heart rate and exercise. And as you increase your activity, your heartbeat does beat faster to supply more blood to your body. And this is the background information you're going to need for our lab today.
Let's look more closely at the human heart. Each time your heart beats, it pumps out blood. Click each term to find out more about your heart.
Okay, so today in our lab, we're going to be looking at heart rate, cardiac output, and stroke volume. So it's really important that you know what each one of these are. The one that you're probably most familiar with is heart rate.
Your heart rate is the number of times your heart beats per minute.
Okay, so that's pretty simple. Stroke volume.
Stroke volume is the volume of blood that is pumped out by a single heartbeat.
Okay, that's the amount of blood that's pumped out by a single heartbeat. And then your cardiac output.
Cardiac output is the volume of blood pumped out to the body in a minute.
Okay,
It
again,
is calculated by multiplying the heart rate by the stroke volume. For example, if the heart rate is 60 beats per minute and the stroke volume is 70 milliliters, the cardiac output is 4,200 milliliters, or 4.2 liters of blood per minute.
okay, notice the cardiac output is a calculation using both the heart rate and the stroke volume. So you're going to be measuring the heart rate and the stroke volume of 3 different runners today, and then you're going to be calculating cardiac output.
In the following investigation, you'll compare the cardiac outputs of 3 people. One person with an average level of fitness, one with an above average level of fitness, and one with a below average level of fitness. Here's what you'll use. A model of the heart. Here's where you will choose which of the 3 individuals to test. Here's where you will choose an activity level. Here's where you'll choose between an open and closed view of the heart. Here's where you can see the person's heart rate and the person's stroke volume. A data table. Here's where you'll record your data. A calculator. You'll click the tools icon on the lower left of the screen and use the calculator to calculate the cardiac output.
Okay, so you're going to be testing 3 different runners, the above average, the average, and the below average runner. You're going to be testing them both at resting and at running. You're going to be measuring the heart rate and the stroke volume, and then you're going to be calculating the cardiac output using a calculator.
Predict the differences, if any, between the heart rate, stroke volume, and cardiac output of these 3 people. Tell whether you think they will be higher, lower, or the same. Type your answer in the box, then click OK.
So you're going to be writing this prediction, or what we have normally known as a hypothesis, of whether you think it's higher, lower, or will it will be the same, the heart rate, stroke volume, and cardiac output of an above average runner, an average runner, and a below average runner. So I want you to make your prediction now. I'm going to have the teacher pause the video and give you about 2 minutes to write your prediction. All right, now you should be momentarily clicking on number 7 of 13. And what the tutorial wants you to do is describe your plan for determining the differences in heart function of the 3 different people. So what you're doing is you're basically writing your experimental procedure. How are you going to test all 3 runners? How are you going to test their heart rate and their stroke volume? And I know this is a little bit different because this is online, but I want you to give an attempt here in the plan, and then it's going to go through the plan with you. So again, I'm going to have the sub pause the video and give you about 3 minutes to write your plan. All right, you should have your plan written in the box, and once you hit OK, and I have to type something, your plan. This is going to be your plan, not my plan.
Check your
And
plan.
now you're going to check your plan.
Did you set a goal and include these steps? Choose a person, record their heart rate and stroke volume when resting and running. Repeat with people of other fitness levels. Calculate the cardiac output for each case. Analyze the data and draw conclusions. If your plan does not include these steps, you can change it. Once you've finished, click the next button to move on.
All right, so did your plan include these 4 steps? If not, I want you to go back up to your Make a Plan box and modify your Make a Plan box. And again, I'm going to give you about 2 minutes to modify your plan, and then we'll move on to actually collecting our data. So we'll pause the video here. All right, now your plan should be complete. And now we get to do the
Now you
experiment.
can run the model. Choose the athlete by clicking the person with the above average fitness level.
Okay, so I want you to choose that person.
First, run the simulation with the activity level set to rest. Click here to run the simulation.
Okay, now here's the setting that shows rest, and you're going to do it resting first, and then you're going to drag it over and do running. So to run the simulation, it looks like this.
Move your cursor over the bar graphs to read the heart rate and the stroke volume. Wait until the heart rate stabilizes.
Okay, so if I put my cursor over
Record the
here,
results in the data table.
I can see that my heart rate resting is 53, and I would enter it here. And
Calculate the cardiac output using the calculator.
I first need to get the stroke volume, which is 93 or 92. Whoops. I need to put that up in the stroke volume. And then I need to calculate the cardiac output, which is your stroke volume and your heart rate per minute. Now it's time to calculate the cardiac output. Again, your calculator is down in the little tools. And to calculate cardiac output, here's my little calculator. I'm going to take 92 times 53, and my cardiac output is 4,876. Now, you're going to test this now with the patient or with the athlete running, and you're going to calculate again the cardiac output, finding the heart rate and the stroke volume. And once you finish with the above average runner, then you're going to do the average runner and the below average runner the same way. So this is going to take you about 5 or 6 minutes. So I'm going to have the teacher pause the video, and I'm going to let you use your iPads to get the data from this experiment. Okay, you should have collected all of your data for all of your patients, your above average patient, your average fitness level patient, and your below average level fitness patient. You should have calculated the cardiac output. And what the lab wants you to do right now is to compare your results of the 3 individuals. What I would look at is I would look at the cardiac output numbers. I would look at the cardiac output from the above average fitness level to the cardiac output of the below. And not only notice the difference between the 3 runners, but notice the difference between resting and running of the person who is above average compared to the person who is below average. I'll have the sub pause the video now for, again, about 3 minutes while you compare your results. All right, here's what I noticed when I looked at the data. I looked at, first of all, the person with the above average fitness level, and that the cardiac output of that runner does not change that much really from resting to running. It's maybe about a 3,000 amount difference. But when you take a look at the cardiac output of the below average runner, when they are running, their cardiac output is almost 3 times greater. So in other words, it's working 3 times as hard compared to this isn't even working half as hard. So notice there is an advantage of the above average fitness level person to when they're exercising for their heart and the amount of blood that it has to pump out. All right, going on to the next page. Oh, I have to continue this investigation because I did not do something here. So it says you have not fully completed this investigation. Please check on the screen for remaining activities. I think I just forgot to hit OK. And indeed, I think that was the fix. So now I get to move on.
The athlete's heart has a larger stroke volume than the heart of a person with an average fitness level. The athlete also has a slower heart rate. This means that the athlete's heart is more efficient. It can pump more oxygen to the body with fewer heartbeats. The same relationships apply to a person with an average fitness level as compared to a person with a below average fitness level. The similar cardiac outputs of the people in the 3 fitness levels show that fitness increases the heart's efficiency. Exercise makes strong hearts. How do your conclusions compare to what scientists say? Type your answer in the box, then click OK.
All right, I'm going to have the sub pause the video again so you can compare your conclusion to what the scientists say here. All right, we'll pause it now. Okay, I compared my conclusion to that of the scientists, and one of the things that I didn't mention in my conclusion that was mentioned in the scientists is that overall, the athlete who is in the best condition has the most efficient heart. So I want you to make sure that you put something like that in your conclusion, and also that you understand that exercise really does matter because your heart doesn't have to work as hard. And your heart is that muscle that never gets to rest. If it's resting, you're not living. So having it not have to work as hard is a good idea. So that's why it's very important to incorporate exercise in your daily activities. All right, moving on to the next page.
Now think about Lance Armstrong, the American cyclist, with a resting heart rate of 34 beats per minute. This heart rate is much lower than that of people with an average fitness level. Based on your results and conclusions, how can you explain this? Click all answers that apply.
Okay, so what do you think about Lance Armstrong? You have 3 different choices here. Based on the results, how can you explain this? Do you think since Lance Armstrong bicycled and worked out that his heart became stronger? I think we should check the box. Do you think a stronger heart means that it is more efficient, and if it has a greater stroke volume than a weaker heart? I think we just learned that in the lab. And it says even though Lance's heart rate is slower than the average heart rate of a person with an average fitness level, his cardiac output is higher. Okay, does that apply?
Right. The heart of a top athlete has a greater stroke volume than average, so even though it has a lower heart rate, its cardiac output is higher. In other words, an athlete's heart can pump more blood with fewer heartbeats.
All right, so the cardiac output of that would be higher of an athlete, like this.
The amount of oxygen your body needs changes with your level of activity. When your body is at rest, it uses less oxygen. When your body is running, it needs more oxygen. Choose 2 ways your body adapts to increased activity levels.
All right,
Click the correct answers.
What do you think are the 2 ways? So with increased effort in your body, you should have an increased heart rate. So with increased effort in your body and with a greater demand of oxygen, you should have, in the short term, developed a stronger heart.
Immediately after your body's activity level increases, your heart rate increases. This is the short-term adaptation. Another solution takes more time. In the long term, with exercise, your heart can become stronger. A stronger heart can pump more blood to your body than a weaker heart in the same amount of time.
All right, last page.
You've learned a lot about what makes a healthy heart. Before we finish, let's take a quick look at the main points you covered. When a person's activity level increases, his or her body needs more oxygen. By pumping more blood through the body, the heart helps deliver the oxygen it needs. A stronger heart has a greater stroke volume and a greater cardiac output than a weaker heart. This means that it pumps more blood per beat and more blood to the body per minute than a weaker heart. A person can develop a stronger heart through regular exercise. Now that you've finished the lesson, click the lab report button to save or print it.
All right, when you click on the lab report button, it's going to save it. We will not have the option to print it. So right now, I'm not going to have you print it. I'm not going to have you take a screenshot. We'll just end the lab knowing that we were able to work through it. Actually, this is what the page that I do want you to take a picture of. I changed my mind. If you go to screen 8, do it, if you take a picture of this screen, then you can upload that screenshot into Schoology, and you can create a note, or you can directly just put it into Schoology. So take a screenshot of this, and this is your proof that you did the lab today. I'll give you about 3 minutes to do this, so I'll pause the video and then we'll see if you can get it uploaded into Schoology. So on Schoology, under the human body, I want you to find the circulatory system folder. Then the assignment that you're going to upload the picture of that lab to is what makes a healthy heart. Now that you've uploaded your screenshot into Schoology, the remainder of the class, what I'd like you to do is I'd like you to go back to Things to Do. And again, you may have to click on Old Assignments. And what I'd like you to do for the remainder of the class period is do the circulatory and respiratory tutorial. And you do not need to record anything. This is just a listen and learn. And we will be ready.
Welcome to the lesson, the circulatory and respiratory systems.
We'll be ready to dissect our hearts tomorrow. So I hope you enjoyed the lab. Make sure it's submitted and go through this tutorial, and you will see you tomorrow.